Question 1. Find the derivative of these expressions. I will solve these questions using two approaches. First, using direct differentiation, and then solve using chain rule. Y equal 2 square root of 5x minus x cubed. Direct differentiations. dy over dx equal to half power 5x minus x cubed power half minus 1. Differentiate the inner expression 5x minus x cubed. So we have 2 times half 1. And here you have 5x minus x cubed. Half minus 1 is minus half. Then the inner expressions is 5 minus 3x, 3 minus 1. So we have, here is 5x minus x cubed power minus half, and 5 minus 3x squares. So we simplify it to 5 minus 3x squared divided by square root of 5x minus x cubed. Now I demonstrate using chain rule. Okay. Y equal 2 u function x half, where I let ux equal 5x minus x cubed. So du over dx equal 5 minus 3x, 3 minus 1. So we have 5 minus 3x squared. Now we solve dy over du equal 2 half ux power half minus 1 equal ux power minus half. Therefore, dy over dx equal dy over du multiplied by du over dx. Now we put in all the expressions. It's ux minus half, and du over dx is 5 minus 3x squared. So we have u is 5x minus x cubed power minus half 5 minus 3x squares. So when we simplify this expression, what you have is 5 minus 3x squared divided by square root of 5x minus x cubed. Question 3. Find the gradient function of these expressions. I will solve using two approaches. One, direct differentiations, and the second approach is making use of chain rule. Direct differentiation. Fx equal 3 5 minus x squared power minus half dfx over dx equal 3 minus half 5 minus x squared minus half minus 1. And now differentiate the inner expressions 5 minus x squared. So we have minus 3 over 2 5 minus x squared power minus 3 over 2, and differentiate 5 is 0, 2x 1 equal minus 3 over 2 5 minus x squared power minus 3 over 2, and we have minus 2x. So the final expression is 3 over square root of 5 minus x squared whole thing cube. And now I differentiate using chain rule. Where I let ux equal 5 minus x squared. And so du over dx, we have 2x is minus 2x. And function f(x) equal 3 ux power minus half. And dfx over dux equal 3 minus half ux minus half minus 1 equal minus 3 over 2 ux power minus 3 over 2, and it is minus 3 over 2 square of ux cube is 5 minus x square cube. And so we have dfx over dx equal dfx over dux multiplied by dux over dx, and we have minus 3 over 2 square root of 5 minus x squared cube multiplied by du minus dx is minus 2x, and so we have 3x over square root of 5 minus x squared cube. Question 3. Differentiate these expressions. The formula to use is d over dx sine x equal cosine x. So when we differentiate directly, d over dx, the whole expression is 3 sine 2x minus 5. We have 3 differentiate sine x is cosine x, so we have cosine 2x minus 5. Now we differentiate the inner expression is 2x minus 5. So we have 3 cosine 2x minus 5. Differentiate 2x is 2, differentiate 5 is 0. So we have 6 cosine 2x minus 5. Now using chain rule, using chain rule. We let y equal 3 sine 2x minus 5, and we let ux equal 2x minus 5. So we have du over dx equal, differentiate 2x is 2, differentiate 5 is 0, so it's 2. And y becomes 3 sine ux. And so when we differentiate dy over dux, we have 3 cosine ux equal 3 cosine, and ux is 2x minus 5. 2x minus 5. Now we apply chain rule, dy over dx equal dy over dux multiplied by dux over dx. So we have dy over dux is 3 cosine 2x minus 5, and du over dx is 2. So we get the same expression, 6 cosine 2x minus 5. Question 4. Find the gradient function of y with respect to x. The formula to use is dx cosine x equal minus sine x. First, we differentiate the function directly. We have dy over dx equal, for differentiate cosine is minus sine 3x minus 2 pi. Now we differentiate the inner expressions is 3x minus 2 pi. So we have minus 4 sine 3x minus 2 pi, and then differentiate 3x is 3, differentiate 2 pi is 0, since 2 pi is a constant. So the final expression is minus 12 sine 3x minus 2 pi. Now I demonstrate solving these expressions using chain rule. Whereby I let ux equal 3x minus 2 pi, and so my y becomes 4 cosine ux, where dux over dx equal, differentiate 3x is 3, differentiate 2 pi is 0, so I have 3. And when I differentiate dy over dux, I got 4, differentiate cosine is minus sine ux. So it's minus 4 sine ux. And now using chain rule, dy over dx equal dy over dux multiplied by dux over dx, where dy over du is minus 4 sine, is minus 4 sine ux. Ux is 3x minus 2 pi. 3x minus 2 pi, and du over dx is 3. And so the final expression is minus 12 sine 3x minus 2 pi.